Okay, class, welcome to Julia's classroom. Today we're going to talk about stars. And no, I do not mean movie stars that you read about in People and Us. I mean the ones in the sky. Okay, now who's seen Lion King? Yeah, Lion King is a great movie. Okay, do you remember that scene where Timon and Pumbaa are laying on their backs looking up at the stars, and Pumbaa's like, Timon, what do you think the stars are? Like, what are those things up there? What are those sparkly things? And Timon says, well, Pumbaa, they're just a bunch of little fireflies that are stuck up in that bluish black thing. And Pumbaa's like, really? I always thought they were big balls of gas burning millions of miles away. And in this case, Pumbaa is finally right. Stars are big balls of gas burning millions of miles away. Now, there's a bunch of different kinds of stars, actually, based on size and color. And the color of stars depends on their heat, actually. And if you think of a flame and the different colors in the flame, stars operate in the same way. Now, if you look at the very bottom, it's going to be blue, and that's where it's really hot. So the hottest stars are blue. And then in the center, it's like a yellowish-orange color. So that's not quite as hot, but still hot. And then the very tip is red, and that's actually cooler. So, the stars we're going to talk about are dwarf stars, giants and supergiants, and then stars that are like very faint and virtually dead stars. And stars usually go through all three phases in their lifetime. Now, dwarf stars are very young and small. They're very young in like a figurative sense, in that the average life of a dwarf star is about 5 billion years. Stars live for a very long time. Okay, so these are fueled by a process called nuclear fission, and we're not going to go into that because that's really complicated, but that's a fun fact, nuclear fission. And what it does is it turns hydrogen into helium.
Like, you can't abandon me all by myself.
No.
Pretty crazy. You guys sounded like practice.
Alright, so, red dwarfs are small and cool and relatively faint, and they're actually the most common star in the universe, but they're the ones you see the least typically because they are so faint. Another kind of dwarf star is yellow dwarfs, which are medium-sized and yellow. And does anyone know what a yellow dwarf star is in our solar system?
The sun.
The sun! The sun is a yellow dwarf. Yep. Okay, so now we're going to talk about giants and supergiants. Now, giants and supergiants are usually the second stage a star goes through. The dwarf stage is the first stage. Giants and supergiants are the second stage. And these are large and they're old. Now, these are the stars you most commonly see in the night sky, even though they're rare, especially supergiants, because they're so bright. Even when they're really far away, you still see them. Okay, so these are so large because as the star gradually goes through the gas supply, it's going through nuclear fission and starts to run out of gas, what happens is the core starts to get smaller and smaller. But as it gets smaller, it gets more compact, so it gets hotter. And as this happens, it starts burning helium instead. So, what helium does is it burns a lot faster than hydrogen, so the additional heat ends up pushing the gas a lot farther away from the core, so it expands really big. It's kind of like hot air balloons, and that the hotter the air gets in the hot air balloon, the more it expands, which is why hot air balloons then go farther into the sky. A couple types of giants are red giants, which even though they're called red giants, they're typically orange. And they, an example of a red giant is Betelgeuse, which is one of the stars in Orion, you know, the constellation Orion, the one that has the bell. Yeah, Betelgeuse. And then another kind of giant is a blue giant, which is incredibly hot. Again, think of the flame, blue giant. And these are incredibly bright, so you typically see these in the night sky. And then supergiants are pretty much giants that are really, really, really big. And some of them can be as large as our entire solar system. One star as big as our entire solar system. The supergiants are huge. Now, the cool thing about supergiants is that when they die and explode, they explode in an explosion called a supernova. And I actually have a picture of a supernova, if I can find it. Supernova explosion. So, you can actually see these when astronomers can predict them. So, that's really cool. And then what happens after the supernova explosion is supergiants typically turn into black holes. What happens is the smaller gets smaller and smaller and smaller and just sucks in on itself and turns into a black hole. I don't know if this is a real black hole, but it looks pretty cool. So what black holes are is that stars are actually held together by gravity. So what a black hole does, what happens, is that gravity just sucks in on itself and it just becomes this giant vacuum in space. Like the same vacuum that you clean the floor with, that's what a black hole is, but it just sucks everything into it, including light. And we don't know what happens to it, just because that's still a mystery. Alright, so the last stage stars typically go through is when they become faint and pretty much dead, like the end of their life. And they usually turn into white dwarfs, like our sun will eventually turn into a white dwarf after it becomes a red giant. And white dwarfs are very small, they're very dense, and they're very hot. They're about the size of the Earth, but like a lot heavier. And another kind is a neutron star, which is also small and very dense. And it actually only has a diameter of about 5 to 10 miles, and you can see 5 to 10 miles, which is usually how far away like school is or something like that. Alright, so the last thing we're going to do in this lesson plan is go through what the sun is going to be like through its successive stages. So the sun right now is a yellow dwarf, as we established, and the sun is about 5 billion years old. But our sun will probably live around 10 billion years old. So it's about halfway through its life. Now as it gets towards the end of its life, what's going to happen is it's going to start to run out of fuel, like we reviewed with giant stars, and then what's going to happen is the core is going to get smaller, and then it's going to expand because it's going to be burning helium gas, and it's actually going to get so big that it's going to engulf the Earth. Now, I don't know if humans are still going to be around at this time, but let's hope not, because that wouldn't be good. Alright, so after it burns through all its helium, the core is going to get smaller, and is going to turn into a white dwarf, one of those pretty much dead stars. And then the excess gas that has been emitted is going to just be ejected into space and turn into a planetary nebula. Pretty cool. You can see these sometimes through a telescope. Alright, so what I want you all to do is I want you to come up. I need 4 volunteers. 1, 2, 3, 4. I want you to act out the stages of the sun. Now, Sierra, I want you to be the yellow dwarf. So I just want you to stand here and I want you to stand. There's the yellow dwarf. Alright, now Hillary, I want you to explode. You're going to be a giant. Yep. Alright, now Jen, you're going to be really small, and you're going to be the white dwarf, and you're going to be the planetary nebula. So go like this. And those are the stages of the sun. Alright, great job, class. That's all for today.